Hey guys, so I hope everybody is safe and healthy and happy wherever you may be. I'm gonna attempt this for this first video. I think it's gonna work out okay. I am gonna have to move quickly though, so if feel free to stop and back up and do as much as you want. But the longer the video is, the longer it takes to download to YouTube, so or to make into a video. So what we're doing is we're breaking 6.4 into two sections. The first one is just one rule called separation of variables. And so what happens is almost like implicit with derivatives, where you have two functions being multiplied. So one's in terms of x and one's in terms of y. So what we're going to do is exactly what it says there. Here's an introductory example where what I'm going to show you with several steps. I'll make sure and show it to you as we do it. But I want to basically get my x's on the right and my y's on the left. So I'm going to start by multiplying by dx to both sides. So I would have dy equals 2xy squared dx. Sorry for the handwriting here. I got to get used to this. And then we want to divide by y squared, basically. So what I'm showing you here, I'm not going to show in every example. I'm just doing it for this one. And then after that, you can always pause and back up if you need to. But I want to write this as y to the negative 2 dy equals 2x dx. So just use it a little bit of algebra to make this happen. And once you get here, now we're going to integrate both sides. So I'm going to integrate. This side over here gives me negative y to the negative 1 plus c equals x squared plus c. I don't know what this little mark right here in the middle is for. Okay, so now the c, so if you think about taking a constant and subtracting it to another constant, you really just have a constant. So it's not that these two will cancel out, it's that they're two different constants. So you're basically just taking this constant and adding it to this one. So we're just going to keep that plus c over here on this side and get rid of it on the left. All right, so now since we have a negative, and then we have this 1 over y. What we're going to do to get our function for y, because that's our goal, is to get y equals what? Since this is what we're going to do is just reciprocal both sides. Since this is actually negative 1 over y, like that, I'm going to reciprocal that, which means I have to reciprocal the other side. So just to make it easy, that's just a quick little way to do that. I'm also going to multiply by negative 1. So it would end up being negative 1 over x squared plus c. The x squared plus c is together. It's all in the denominator. For the next example, now we're going to do the same thing, except now we have values for x and y. So once we get to a step that we have our c, we can actually find it. Okay, so I'm going to start out by calling this dy dx equals x squared y squared. And now I can separate my variables. So over here on the left, I'm going to have y to the negative 2 again dy. On the right, x squared dx. Now we're going to integrate both sides. So again, we have negative y to the negative 1. And I'm not going to put the plus c on this side because I already did it on the last one. And so you'll just realize that that's going to end up on the right. So this would be x cubed over 3 plus c. Now that's plus c to the whole thing. Except this time we know that y is equal to 1 and x is equal to 1. So what we're going to do is make that substitution. So we're going to plug in 1 here, which just gives me negative 1. We're going to plug in 1 here, which gives me 1/3. And then we're going to solve for c. So when I solve for c, I actually get negative 4/3. Okay, so my final answer then is going to be my original function. Well, I'm sorry, we're not at the original yet. Let's do this one step at a time. So we'd have x cubed over 3 plus, no, I'm sorry, minus 4/3. Okay. And then now we're going to use that same trick that we did before where we reciprocate everything and make it negative. So this would be negative 3 over x cubed minus 4. If you're following me in the book, though, on page 350, they don't leave the answer like that. They just multiply the bottom. And just so if this happens in your solutions manual, they're multiplying the denominator by a -1. So the answer they're getting, which is exactly the same thing, is this. And all it does is negate the denominator. This is what your examples for homework are actually odds. So what I want you to do for this even number 4 is pause and play. So I want you to pause the video, try it yourself. When you get stuck or when you need to, you can turn the video back on, and then I will you can walk through the steps that I have. Okay, so we're going to start this one out by moving, dy, and then we have 2x dx. And when we integrate both sides, this is like 1 over y, and the integral of 1 over y is natural log of y equals x squared. Okay, now this is a little funky because we need to get that y out, and so we have to remember our rules for logs and natural logs. What we're going to do is actually e both sides. So we're going to make a base of e. So we have y equals e to the x squared plus c. Okay, now follow me here. Don't get off and get sidetracked or looking at the wall somewhere, because this could be confusing. Since this is an adding exponent, I can actually write it as multiplication. So this will be e to the x squared times e to the c. So isn't that true? Just say yes. Because when we multiply, we're going to add exponents. What we're doing is we're going backwards. We're taking an adding and breaking it up into multiplication. Now, e is just a constant, and I'm raising that to another constant. So what happens is you really just get a constant here. So we're going to look at this as y equals, I'm going to take that constant and put it in front. So it's going to be the constant of c times e to the x squared. All right, now I can plug in my 0 and 3, and that gives me c equals 3. And now my function is just 3e to the x squared. All right, and then last example here, and this is when you can sometimes see U substitution inside of the problem. So let's first start by separating variables. I want my x's to stay over here and my y's to go to the other side. So that would look like this. Sorry, I don't have a way to stop my pen from making that incredibly annoying noise when you listen to this. I'm very sorry. I don't have a way to stop it. Unless you know of a way, you can let me know. Okay, the integral over here on the left is tangent inverse of y, and that is going to be equal to, whoa, wait a second, what the heck am I supposed to do here? So on this side, when you get ready to integrate, you got to think U substitution. So we're going to make u equal to x squared. We're going to make du 2x dx, which works perfect because I have a 2x dx. And I'm going to make this, well, okay, let me do it over here. Continue in blue. So this would be integral of e to the u du once I did my substitution. So I'm going to take the answer to that, and I'm going to put that in my problem now. So this would be integral of e to the u is e to the u, and that's where my plus c will follow. All right, and then in order to take care of this guy, I need to somehow cancel out a tangent inverse. So what I'm going to do is I'm going to actually tangent the whole equation. Ooh, can't see that there. Run out of room. I'm going to tangent both sides, basically. So my tangent inverse cancel. That leaves me with y. And now I have the tangent of e to the u. Now remember, u was x squared. So we're going to make that e to the x squared plus c. And we do have to leave the e to the x squared plus c in parentheses because we took the tangent of the whole thing. So it's very important to leave it that way. Okay, so what I'd like for you to do is try just part of your homework. Again, I don't have the rest of the notes yet. I'll get those prepared for you soon. Right now, you can do 1 through 9 odd, use your solutions manual, and let me know. I'll give you an idea of how you can let me know if you have questions. All right, good luck.